Now we will have mass-to-mass conversion. But before we have our mass-to-mass conversion, I'll prove to you that law of conservation of mass applies to a balanced chemical equation. So let's assume we have the composition of water to hydrogen and oxygen. Of course, you have to balance first the chemical equation. So to balance the chemical equation, you put 2 beside water as coefficient and you put 2 beside hydrogen as coefficient. Now you have a balanced chemical equation. Now, from our previous lesson, we know that the 2 coefficient here indicates that we have 2 moles of water. Here, we have 2 moles of H2. And the 1 coefficient beside O2 means you have 1 mole O2. Now, let's get the molecular weight of each compound. So, the molecular weight of water is 18 grams per mole. The molecular weight of H2 is 2 grams per mole. The molecular weight of oxygen is 16 from the periodic table, but you have 2 oxygen atoms, so that would be 32 grams per mole. Now, let's get the mass of each compound. So, since we have 2 moles of hydrogen, 2 moles of water, and we know that the formula mass of water is 18 grams over mole. For this reaction, we have 2 times 18 is 36 grams. So, meaning the total mass of our reactant is 36 grams. Now, how about hydrogen? Since we have 2 moles of H2, we have the molecular weight of H2 is 2 grams per mole. So, 2 moles of water is producing 4 grams of H2. This is H2O. How about oxygen? Since we have 1 mole of oxygen and the molecular mass of oxygen is 32. So meaning 36 grams of water is producing 32 grams of water. If you notice, the reactant is 36 grams, and if you add the amounts of the products, it's also 36 grams. That's 4 plus 32. So, a balanced chemical equation is showing that law of conservation of mass is true in a chemical reaction.